to help us understand percent change and the difference between an exponential function like y equals 2 to the x and a linear function like y equals 100x, we're going to take a look at this example. So we're going to start out by just looking at what happens between day 2 and day 3 on both types of functions. So the formula says that if we use consecutive x values, which 2 and 3 are consecutive x values, you take the y final, which would be the 8, minus the y initial, which would be the 4. So we would have 8 minus 4 all over the y initial, which is the one that we started with. It grew from 4 to 8, so 4 is the initial value, times 100, and that will tell us the percent change. So 8 minus 4 is 4 over 4 times 100. 4 over 4 is 1 times 100. And so that makes our percent change 100%. So here, moving from 4 to 8, we have a percent change that's equal to 100%. Now, this makes sense. 100% of 4 is 4. So you already had 4. But you get 100% more of that. So if you already have 4 and you get 100% more than that, that means you have 2 4s, which is 8. Hello, Math 2 students. Today we're going to figure out how to find the percent change in an exponential growth or decay function. The formula for finding that percent change is the percent change is the final value minus the initial value. So the change in values divided by the initial value times 100 to change the decimal into a percent. So using variables, our formula is going to look like this. This means change, so the change in percent or the percent change is the final y value minus the initial y value divided by the initial y value, and that will give us a decimal. Then we multiply by 100, and that will give us the percent change. Now we're going to look and see what happens between day 2 and 3 in the linear example. So we take our final value, which is 300, minus our initial value, what we started with, which is 200, all over our initial value, which is 200, times 100, and that 100 will change it into a percent for us. So 300 minus 200 is 100 over 200 times the 100, and then 100 over 200 is 0.5 times 100. And when you do that on a calculator, or if you know the answer in your head, that will come out to 50%. So the percent change here is 50%. So what that means is you started with 200, and if it's going to have a percent change of 50%, you get your original 200 plus you get 50% of that added on. So 200 plus 50% of 200, which is 100. So 200 plus 100, that's how it grew from 200 to 300, and that's a percent change of 50%. So to help you see really the difference between exponential growth and linear growth, now we're going to skip ahead from day 3, and we're going to use these 2 consecutive days. How much did it grow between day 20 and 21? And we're going to take a look at it on both graphs. So again, to calculate the percent change, you start out with your final value. So you got 2097152 minus your initial value, 1048576, all over your initial value, 1048576. And we're going to need to multiply that times 100 to change it into a percent. So when we subtract these 2 numbers on the top, the answer that we get is 1048576 over 1048576 times 100. Well, the top and bottom of this fraction are the same, so it's 1 times 100, which is 100%. So between the 20th day and the 21st day, the percent change is still 100%. So what's causing this exponential function to grow so quickly is we only started by taking 100% of 4. Now we get to grow by 100% of 1,048,576. So we get to have this amount plus we get to add on 100% of this amount, and that's how we end up with 2,097,152 on day 21. Okay, so now we're going to take a look at the linear function and see what happens between day 20 and day 21. So we start out with our final value, 2,100, minus our initial value, which is 2,000, over our initial value, times 100 to change it into a percent. So 2,100 minus 2,000 is 100 over 2,000 times 100%. And so that's going to come out to 1/20th or 0.05 times 100, which is 5%. So the reason that exponential growth grows more quickly than linear growth in this example is on all linear growth problems, as your initial value gets bigger and bigger and bigger, the percent increase of your value is smaller and smaller. So at first, it was growing by 50%, but as the days go by and you get to day 20, between day 20 and day 21, it only grew by 5%. So that's how linear growth works. When it comes to exponential growth, between day 2 and 3, it grew by 100%. And between day 20 and 21, it was still growing by 100% every day. If we came down to, say, day 50 and day 51, that would still be growing by 100%. And so exponential growth happens quickly because it's always growing by the same percentage no matter how many days go by. In linear growth, as the number of days go by, the percent change is less and less and less as time goes on. Does the function represent growth or decay? What is the percent change? So here's our function, and we already know that it's going to be a decay function because our b value is a proper fraction. It's in between 0 and 1. But I'm going to show you now how the percent change just reinforces that it is a decay problem. Now all I need is 2 consecutive x values, and I can find my percent change because I know from the last example that in an exponential function, the percent change stays the same no matter how many x values you've looked at. So we're going to look at an x value of 0 and an x value of 1 because those are the easiest two to calculate. So if I do 1/4 to the 0 power, anything to the 0 power is 1, and 1/4 to the 1 power is 1/4. So now if I want to find my percent change, I take my final value minus my initial value over my initial value times 100. So in this problem, 1/4 minus 1 would be negative 3/4. So I have negative 3/4 over 1 times 100. And if you take negative 3/4 divided by 1, obviously you get negative 3/4. And then negative 3/4 times 100, if you turn it into a decimal, will be negative 75%. So the percent change in this problem is a negative 75%, which means when you go from 1 to 1/4, you have lost 75% of the value that you had. All right, again, we're working with an exponential function. We want to know if it's growth or decay. This one is obviously growth because our b value is greater than 1, and we want to know the percent change. So I just need to use, because it's an exponential function, I know that the percent change will be the same no matter which 2 consecutive days I pick. So if I pick day 0 and day 1, it's easy to calculate, and those are consecutive days, and it's exponential growth, so this should work out. So 1.5 to the 0 power is 1, and 1.5 to the 1 power is 1.5. So in order to calculate my percent change, I take my final value minus my initial value, over my initial value times 100. So 1.5 minus 1 is going to be 0.5. So I have 0.5 over 1 times 100, which is 0.5 times 100, which is going to be 50%. So the percent change is 50%, which makes sense. I started with 1, and if the percent change is 50%, I need to take this 1 plus I get 50% more, which is half of 1, which would be 0.5. So my total after 1 day is 1.5. The great thing about exponential growth, or the thing that's amazing about it, is that we will have that 50% growth in between every 2 consecutive days for as many days as we want to calculate it.